Hello, dear students. You're most welcome for our Pure Mathematics Differentiation 1. Did you know that the concept of differentiation was first introduced by Sir Isaac Newton and German mathematician that is Gottfried Wilhelm Leibniz in the centuries of 17th? Of course, I believe you don't know, but now you need to know. They developed the methods of fluxions, which is now known as differentiation. And that's how we come to coin the word fluxion into differentiation, basically great to English. So today we will delve into the world of differentiation and explore its significance in mathematics and other related sciences. When we look at what we have on the board, we have gotten case one and then case two and our introduction. And we already know that the gradient of a straight line which passes through the points, take for instance A with the coordinates x1, y1, and also B maybe coordinates x2 and then y2 is given by m, and where m is given or symbolized as the gradient of a given line, be it a curve or a line. But m is always symbolized as a gradient in mathematical, basically as a mathematical symbol. And the whole expression is given by the change in y divided by the change in x, where change in y is given by the second point along y-axis and the second point along x-axis. So we shall then be having gradient m subscript a b giving us y2 minus y1, which is a change in y, divided by x2 minus x1, which is a change in x. So already we have also seen that the gradient of a straight line is also the same throughout, which is not true when it comes to curves. So for case 2, we are going to consider a curve, which is basically having points A and B, the same as case 1, points A and B. We should remember that the gradient changes as you move from point A to B along a given curve. So the gradient of a curve at a point P is then the gradient of the tangent line to the curve at point P. Let's look at how we can then get the gradient of a given curve using differentiation from the first principles. Using differentiation from the first principle. This is one of the methodologies that we shall be applying in the solving problems under differentiation as a concept that we are immersing ourselves in today. Let's try to assume or consider the point P with coordinates x1, y1 on the curve C shown in the diagram below. You have gotten along the x or the horizontal line, you have point X, which is coordinating or projected to point P. You also have point X plus delta X, which is projected to point C. And at point X plus delta X, it's basically uh, the second value of X along X axis. And then you also have along Y axis, you have Y plus delta Y, which is the second point or the second value of Y. You also have a curve, which is curve PQ, rather a curve C, which is having a straight line PQ. And we are saying PQ is basically going to give us yet another term in mathematics. So basically what we need to find is to find the gradient of a curve at particular point, and that's point P, which is having the coordinates x and y. But remember one thing, that delta x and delta y are the small increments or the small increase in x and y respectively. In some other books, they may be referring them as small changes in x and y respectively, which are still synonymous words to be applied here, and they all mean the same thing. So let's try to assume and take a point Q, which is having coordinates x plus delta x. Already we have said delta x is a small increment in x And also the coordinate, we have another value y plus delta y, where delta y is the small change or the small increment in y, such that it has gotten such coordinates, and we're having delta y, delta x all defined. So we are saying the straight line PQ. Straight line PQ is basically along the curve C. It's called the chord of the curve C. And as the distance delta x becomes smaller, then point Q moves closer, or rather it approximates to P, and the chord PQ approaches the position of the tangent at P. Let's try to assume that we have point P, and along point P horizontally we have the tangent at P. Vertically, we have some line that is drawn at tangent to point P, rather point Q from P. And you have along the curve C, you have several points, and that is Q2, Q1, and the rest. Basically, we are linking point P and point Q to have the tangent there along the curve. So the gradient of PQ is given basically by, we said earlier, for the case of straight lines, changes in y divided by changes in x. In the same way also we have the gradient of this curve will be given by the change in x, rather change in y, divided by the change in x. Where change in y, we're having y2 minus y1 divided by change in x, which is given by x2 minus x1. Now, for this particular case, our y2 is given by y plus delta y, and our y1 is given by y. Now, for our change in x, our x2 is given by x plus delta x, and since we have a point P at the neutral point or the origin, we have x1 as being 0. So the whole expression y plus delta y minus y divided by x plus delta x minus x is going to give us delta y divided by delta x. Otherwise, there's actually some mistake. Instead of 0, it's supposed to be x. So that you can have the equation, rather the symbol, basically the illustration for derivative, and that is delta y divided by delta x. So it's supposed to be x plus delta x minus 0 instead of, rather minus x instead of 0. Please, you try to make some bit of correction there. Then we are saying as delta x tends to 0, this is an assumption here, that is delta x tending to 0, delta y delta x will be approaching also the value of the gradient of the tangent at the line P, which is true, and this value is then called the limiting value of delta y delta x, and it is written as the limbs or the limits delta x tending to 0, delta y delta x. And so the limiting value of delta y delta x is basically what gives us the whole Christian name of what we are studying today, and that is the derivative of y, basically with the differential coefficient or the first derivative of y with respect to x, and it is denoted by dy dx. So the whole of our applications, significance, and the implications of this concept will be defined by dy dx, not now delta x, rather delta y delta x. Remember, delta y delta x are basically approximations, and these are small increments. But then after taking the assumption of delta x tending to 0 in a given function, then we shall be remaining with dy dx. So we are saying the process of finding the limiting value in this form is what we call differentiation. The process of finding the limits as delta x tends to 0 with delta y delta x tending to dy dx is what we call differentiation. Now we have the fundamental notes that you have got to always remains once tackling concepts or any challenge or problem within this particular study course. You have not one. Yeah, it's important to note that dy dx does not mean dy divided by dx. It simply means the derivative of y with respect to x. So when you're trying to explain this to your fellows, do not say dy divided by dx. No, we are saying it is the derivative of y with respect to x, meaning you are differentiating y as a function of x. Then note two, in some cases you'll be encountering the symbol d dx. Now d dx will simply mean that it is an operator. It is an operator operating on the function y. And we are saying d dx is also the same as dy dx. We are saying d dx, an operator operating on the function y. So for you to clearly see that, then you can be able to have the whole of d dx or dy dx rewritten as d open bracket y close bracket dx. Now, y itself will be given in terms of a certain polynomial. So, please, this is just an introduction, the complexities, the abstracts, what Mr. Isaac Newton and his friend Leibniz considered with the assumptions and the limits and the small increments and basically arriving to dy dx. And with the subsequent examples that we are going to be partaking in our next session, we shall be dwelling and remaining consistent in the line of these assumptions for us to have the proofs conserved. Otherwise, please, I wish you all the best as we meet in the next session for illustrations covering what we've already discussed. Thank you.